Hey guys, so welcome back to another video. Today we're going to talk about PointSlope Form, our next section of the RF6-7 outcome. But before we get to that, I know a lot of you guys have been stuck indoors at home, so I just want to talk a little bit about making sure you guys are taking care of yourselves, going outside for nice short walks, learning new hobbies, keeping in touch with family and friends. Because I know a lot of you guys are going a little stir crazy right now, so I just want to make sure everyone's doing all right. I know it's a little bit tough, but we will get through all of this. But this is just a little reminder for you guys to check in with your mental health. I know some of you guys might be feeling a little anxious, just feeling a little bit cooped up. But again, don't ignore those feelings. If you're feeling a little down, if you're feeling a little stressed out, about whether it's schoolwork or just life in general, make sure you reach out to someone, talk to a parent, talk to a friend, talk to someone you trust, talk to a teacher. You have a lot of support out there. Make sure you guys are taking yourselves first and foremost. So without any further ado, let's go ahead and talk a little bit about point-slope form. So point-slope form is the second form of linear equations that we're going to discuss in RF6 and 7, like I mentioned. In the previous lessons, we talked about slope-intercept form. So just a really quick refresher here. So slope-intercept form was represented by the equation y is equal to mx plus b. And from here, we were able to garner a couple pieces of information. First of all, your m represents your slope, and your b value, we found out, represents your y-intercept. So we've got two big pieces of information in those two variables, and from there basically we're able to figure out, if we're presented with some sort of graph that looks kind of like this. Let's go ahead and do this one in red. So if I were given this graph here, let's say we know that our y-intercept could potentially be here, and let's say that point is A2, and we were told that the slope of this line happens to be 3. Then from here, we'd be able to figure out that the linear equation that represents this line is y is equal to 3x plus 2. Oops. So from here, we're able to figure out that the linear equation that represents this line is y is equal to 3x plus 2. So that is essentially what we talked about in the last two video lessons, and that was slope-intercept form. Now today we're going to be discussing, like I said, point-slope form, or slope-point form depending on which resource you're using. I like to call it point-slope form. So point-slope form, as you can guess, we're going to have two pieces of information. First, we're going to have a point on the line, and we're also going to have a slope as well. So to kind of give you a little bit of an inside look at what we're going to be discussing over the next 20 minutes or so, if I were to draw a line here, I'm going to go ahead and draw the same line here. And we're going to be given different types of information instead. Now, instead of knowing what this y-intercept is, okay, I could be given some point on this line. So in this case, let's say we're given this point here. Let's say this point is, I don't know, -3. Oops, -3. And let's go -1. Okay, so we have a point on the line. We don't know exactly what the slope is equal to. Okay. Oh, let's scrap that. So we're given that point there, and now we're going to be, instead of given the y-intercept, we're going to be told that the slope here could be, I don't know, let's say 4 in this case. Okay, so given these two pieces of information, we can actually come up with a different type of linear equation, which is what we're going to discuss today. So let's go ahead and talk about point-slope form and discuss what the actual equation looks like. Now let me highlight a couple things first. Again, we have your slope that's given and 1 point on the line. So we have point-slope form being represented by the equation y minus y1 is equal to m times x minus x1. So again, we're going to have your m value here representing the slope. That does not change at all. Okay, and then we're also going to have, in this case, we're going to look at 2 points. We're going to have x and x, or x1 and y1. So we're going to have x1, and we're also going to have y1. All right, now, how do those come about? Well, if I were to go ahead and let's open up a different slide here. All right, so let's go ahead and draw a graph here. And let's say we're given two pieces of information. Let's say we were told that the slope of this graph was 2, and we're given one of the points up here. Now this could potentially be something like 3, 1. We don't know. Okay. And essentially what we need to do is we need to examine a really familiar formula. M is equal to y2 minus y1 over x2 minus x1. All right, so this was the slope formula that we learned about back in RF3. So this should look quite familiar to you guys. And essentially what this tells you is that we're going to have 2 points here that we can use to help us figure out the slope. Now the only thing that's going to be a little bit different, okay, is, now in this case we're now going to be given the slope, and that 3, 1 is going to be what's a little bit different. That 3, 1, okay, is actually part of this same equation. We could consider that 3, 1 representing x1 and y1. Okay, so let me go ahead and write that down. So that could be x1, y1. Now, what happens to the x2, y2? Well, that would just essentially be some other point over here. It could be another point right here. It could be a point right there. We don't really know what it is. Okay, now, just because our slope formula has 1s and 2s doesn't mean we can't change it to something a little bit different. We could change y1 minus y2, or we can have y1 minus x2 minus x2 on the bottom. Okay, so essentially what we've done is we can go ahead and actually substitute in our values that we just figured out. So we have 3 and 1, and we have the 2 there. So we could have 2 is equal to y2 minus 1 over x2 minus 3. All right, now what's going to happen here is, let's say I were to go ahead and multiply that x2 minus 3 up onto both sides. So I'm going to go ahead and multiply this side by x2, multiplying by x2 minus 3 on the right side, which means that on the left side, I'm going to multiply by x2 minus 3 as well. So if I clean this up a little bit, I'll end up with x2 minus 3 times 2, or in this case, I'm actually going to put that 2 in front, is equal to y2 minus 1. So y2 minus 1 will give me my equation there. Now we can clean this up a little bit more just so it looks quite familiar. I'm going to actually switch around the order of what I just wrote down. I'm going to switch the right side here and just move it onto the left side. So I'm just going to say y2 minus 1 is equal to 2 times x2 minus 3. Now instead of calling it y2 and x2, I could also just go ahead and have y minus 1. It's the only y that I have in the equation right now. So y minus 1 is equal to 2 times x minus 3. And that represents this line right there. That's the equation for that line. Okay, just because we are given two other pieces of information. We're given a point on the line and we're given the slope. So let's go back and compare that to exactly what we're discussing right now. We have y minus y1 is equal to m times x minus x1. So again, let's go ahead and do this without any visual representation. So if we're given a slope of 3 and a point 0.54, we can identify that m is equal to 3. M is equal to 3. And you have your 0.54. We know that 0.54, we have your x1 there, and we'll have your y1 there. So let's go ahead and fill those values in. So we have 3, then we have 5.4 as your two values. Okay, remember in an ordered pair, x comes first and then y. We want to go and substitute each value into PointSlope form. All we're going to do is we're going to take a look at our original equation, y minus y1. So you've got y minus your y1, which in this case is 4, is equal to your slope, so m, which is 3 in this case. So 3 times x minus your x1. So in this case, x1 is equal to 5. So we have your equation y minus 4 is equal to 3 times x minus 5. And that ends up being your linear equation representing some line with a slope of 3. And it goes through the point 5.4. So something we need to be really careful about are negatives. Okay, and I know a lot of people don't really like negatives or don't quite understand negatives yet. That's okay. So let's try this one out. We're given a slope of 2 and we have a point -2, -1. We've got a couple things here. We know that your slope is 2, so that's going to come right over here. And then we're given a point -2, -1. So that -2 and -1 will come into here. Let's go and fill those in first. So you've got 2, -2, and -1. And we're going to go ahead and make those substitutions. Okay, so here, remember we're still keeping the same format, y minus your y1. So we got y minus a -1. So we need to be really careful there. Y minus a -1 is equal to m, so m is a +2, times x minus your x1, so x minus a -2. We can simplify this a little bit. We don't want to go y minus a -1. Let's clean it up. When we subtract a negative, we end up adding. So we have y plus 1 is equal to 2 times x plus 2. And we'll come up with an equation that has a slope of 2, and it goes to the point -2, -1. And that's represented by the linear equation y plus 1 is equal to 2 times x plus 2. We can try a couple of examples here. We're given, again, a slope and a point on the line. So after the first or second example, what I'd like for you guys to do is to pause the video, try out the last two on your own. So we'll go ahead and start off with the first example. So we know that your slope is 4, and we have your point 2, 5. So what we're going to do first is I'm going to go ahead and rewrite PointSlope form up here. We got y minus y1 is equal to m times x minus x1. So we know exactly where to substitute our values. So I'm going to go ahead and do that. So now I've got y minus 5, because we know that, and maybe I'll write it just above here, I'll have x1 and a y1 right there. So x1, let's clean that up. So you've got an x1 and a y1 right there. So you have y minus a +5 is equal to your slope, which in this case is m. So you got the 4 times x minus x1, which is the 2 there. So x minus 2. And we have your linear equation there. Okay, and again, just to highlight, where does that 4 go to? That 4 comes right over here. And your 2 and 5 come into these two slots here. So 1 and 2. Okay. The second equation, or the second example here, we would end up, maybe before I do that, just again, if you want to try these out on your own, go ahead and pause the video. And we'll have y plus 2 is equal to negative 1, or just a negative. Okay. Negative, and we've got x minus 9. Okay, so some students will ask me, is it okay if I just leave the negative right there? That's absolutely fine. Some of you guys might want to write negative 1 just to remind yourself that the slope is negative 1. That is absolutely all right. And let me clean this up a little bit. So is equal to negative 1 times x minus 9. So some of you guys might like that, just to remind yourself that there is a number there. Some of you guys might just want to keep a negative by itself, and that's perfectly fine as well. Okay, so just for this video, let's have a negative 1 there. Third example, we'd end up getting something like y minus 4 is equal to 7 over 4, and I'm going to write it just like so. So 7 over 4, x plus 3. Okay, again, just a reminder about that negative. Because we have a negative 3 here, in this case, we'd have x minus a negative 3. So when you take away a negative 3, it means you're actually adding 3. For your last example here, we'd end up with an answer of y plus 5 is equal to negative 3 over 2 times x plus 7. All right, moving on, we can go and graph these lines using some information that we can figure out from those graphs and come up with a linear equation in point-slope form. So for example number 1, we're going to identify 3 things, or really just 2 things, your slope m and a point on the line. So again, we want to try to look for some sort of lattice point that can give us some direction as to what's happening in this graph. So looking for a slope here, let's go ahead and choose, we can choose 2 lattice points, doesn't really matter. So let's choose this point right here. So that's one of them. And we're going to choose a second lattice point. Let's choose that one. So we're going up 1, 2, and we're moving 2 to the right. So it's 2 over 2. So 2 over 2 is the same thing as 1. So we can say that the slope is 1 over 1 or 1. Okay, so 1 over 1 means that you're moving 1 up and 1 to the right. So we can write it as 1 over 1 or 1. I'd really prefer for you guys just to recognize that the slope is just 1. Okay, but just for the intents purposes of understanding slope and reviewing it, we know that it's 1 over 1. We want to pick some point on this line. So it doesn't really matter which point we use on this line. We can use any one of them. Let's go ahead and use this one that's a little bit further on the left. So this point right here, we know that this one is going to be 2, negative 3. So 2, negative 3 is my point there. So we know in this case, because it's in the order x, y, our x1 is going to be 2, and our y1 is going to be negative 3. And all we're going to do is go ahead and plug in those values back into point-slope form. So again, as a reminder, point-slope form is y minus y1 is equal to m times x minus x1. So we're going to put those numbers in. So to start us off, we've got y minus y1. So if we're subtracting a negative 3, we are adding 3. So y plus 3 is equal to m. In this case, m was 1. So we can have 1 like so, and we put the bracket beside there. So 1 times x minus x1, so x minus 2. So again, we don't necessarily need to put that 1 there. I'm just putting there just so people can see that there is a number beside it. Our slope is 1, so please don't forget that. And let me just go ahead and highlight where those numbers are going to. So again, your slope is found there, 1, and you will have your plus 3. Remember, that's y minus a negative 3. And you're going to have your x minus x1. So x minus 2 is what we get there. So at this point, I'd like to remind you guys, you can feel free to pause the video and try the next 3 examples out on your own before I continue on. So moving on to example number 2 here. We've got, again, another nice line here. We've got a negative slope, so we can figure out it's a negative slope. Moving from left to right, the line is going downwards. So we can figure out what our slope is. Let's pick 2 lattice points. Let's choose this one here. You got 1 there, and we are also using 1 there. So looking at those 2 lattice points, we're moving 2 down and 1 to the right. That means our slope is negative 2 over 1, or just a negative 2. I'd prefer for you guys just to use the negative 2 there. But understand that a negative 2 slope, or a slope of negative 2, means that we're moving 2 down and 1 to the right. Let's use some point. So I'm actually going to use the y-intercept here. So your y-intercept happens to be 0, 2. And I love using the y-intercept because anytime in math we can use 0 as part of our equation. It makes things so much easier. So that's a tip for you guys. Use any points that have a 0. A point slope form makes things or makes the simplification of things a lot quicker. So we know here that x1 is 0 and y1 is 2. So our final linear equation, once we simplify everything, is y minus 2 is equal to negative 2 times x minus 0. So y minus 2, and I realize I wrote that a little bit small. Y minus 2 is equal to negative 2 times x minus 0. For those of you who are asking, oh, can we simplify this a little bit more? Sure we can. We could actually just go ahead and rewrite it as y minus 2 is equal to negative 2x. Okay, if we want to simplify it fully. But again, I'm not super concerned about that in this particular portion because I just want you guys to be able to use the point slope format. Example number 3, we want to choose 2 lattice points. So let's choose 1 there, and let's choose this one there. We can see that your slope is going to end up being 2, or 2 over 1. Let's use your y-intercept again, 0, 4. Oops, so you got 0 and 4. 0 and 4. 0, 4. And that will give us a linear equation of y minus 4 is equal to 2 times x minus 0. Or if we want to simplify fully, y minus 4 is equal to 2x. Last equation here, or the last example, we want to figure out the slope. So again, choose 2 lattice points. Let's go ahead with this one and this one. We can see that our slope is a negative 2. We're moving 2 units down and then 1 to the right. So we've got a slope of negative 2. Let's choose a different color, negative 2. We've got an x value. Let's go with this one here. Let's say that it's going to be negative 2, 0. Oh, that's a lot messier than I thought it'd be. Negative 2, 0 is going to be my chosen point, my x1, y1. So we got negative 2 and a 0. So here we've got y minus 0 is equal to negative 2x plus 2 as my linear equation. Can I simplify this a little bit? Sure, y minus 0 is just y. So y is equal to negative 2 times x plus 2. Now the last couple slides for today, we're going to talk about how to find the slope given 2 points on the line. So this one, hopefully you guys will see that essentially what's going to happen is if we're given 2 points, we are given an x and a y, and we're given an x1 and a y1, which essentially is asking us to find out what your slope is. Okay, so we're really just using this rearranged slope formula to help us figure out the slope. And then we're going to plug back our values to give us some sort of linear equation. Now our example here, we've got 2 points, 6, 4, and 2, -4. So we're going to go ahead and plug in those pieces of information. So let's say we've got your 6 and 4 there, and 2 and -4. So these pieces, I'm going to say, I've just decided to put them here. And these choices, I've decided to just put them over here. Okay, so we're saying that 6 and 4 are just my x values, and x1, y1 will be 2 and -4. Now, before you guys start to ask me, doesn't matter which one we choose, wait about 2 minutes and you'll find out. So it doesn't matter, but I'll prove to you why it doesn't matter in just a little bit here. So let's go ahead and plug in those values. So I'm going to have my y minus y1. So I'll have 4 minus a -4. So 4 minus a -4. And then is equal to m times, this would be x minus x1. So x minus x1. So 6 minus 2. So this will give me 4 minus a -4 is a positive 8, is equal to m times 6 minus 2, which is 4. So I have 8 is equal to m times 4. I'm going to divide both sides by 4 so I can figure out what m is. So I'm getting rid of everything there, and I get m is equal to 2. Now all I want to do is I want to plug in my values here. So I have y minus y1. So y minus my -4. So y minus -4 is equal to, oops, let's move that down a little bit. We have y minus a -4. Let me see if I can actually move that down here. So our final equation that we get is, we'll have y minus a -4 is equal to 2 times x minus 2. Okay, so y minus a -4 is equal to 2 times x minus 2. I can simplify this a little bit. When you subtract a -4, we end up with y plus 4. Oops. We have a y plus 4 is equal to 2 times x minus 2. And that would be my linear equation that has a slope of 2, and it goes through the point 2, -4. So that goes through that point there in the green, 2, -4. Okay, so going back to this idea of how do we know which one is which? Again, I said it doesn't matter. Now, how do I prove to you guys that it does not matter? Well, let's go ahead and we're going to reverse, okay, what we did here. So instead of x being 6, we're going to say that x is equal to 2. Instead of y being 4, y will now be equal to a -4. So let's flip the page, try it out. So now in this case, we've got y minus 4 is equal to, and we're still going to say that m is equal to 2. And we're going to have x, oops, sorry, not x, y minus 4 is equal to 2 times x minus 6. Okay, Now let's see how do we, or if they are the same line or not. So this is what we came up with just now from here. And the equation from our previous page, and let me draw a line down the middle so we can kind of see the separation in the two. We had y plus 4 is equal to 2 times x minus 2. So this was the equation from the previous slide. Now what I'm going to do is I'm going to ask you guys to go ahead and to simplify everything, and then I want you to isolate for y. So go ahead, try that out on your own first. So pause the video, try that out. So you want to come up with some sort of answer at the end for both where you have y is equal to. So go ahead, try that out. What do we get? Okay, so now that you've given that a shot, we're going to go ahead and we're going to isolate for y. We're going to solve it for y. So let's go ahead and distribute. Y minus 4 is equal to 2 times x, so 2x. Then we have 2 times a negative 6, which gives you a negative 12. So we're going to isolate that y by adding 4 to both sides. So we go plus 4 plus 4. If you're a little confused about what I did over here, I'm going to distribute and multiply those. So we finally end up with, on the left side, y is equal to 2x minus 8. Okay, so that's what we get for this equation on the left side. And we're going to do the same thing now, except on the right side. So let's try that one out. So I'm going to multiply or distribute those out. So we have 2x minus 4 over there on the right. And we're going to try to get that y by itself. So we're going to subtract 4 from both the left and the right sides. And we are now left with y is equal to 2x minus 8. And now the crazy thing is, and hopefully you guys had this wow moment, and that's exactly what math is all about. These are exactly the same. The reason why is because we know that both of these points here, this x and y, x1 and y1, they're both points on the same line. So it really shouldn't matter, okay, where we put them, as long as we're putting them where the y's is supposed to be and where those x's are supposed to be. Okay, so don't stress about that portion. You'll see, or you saw, that we just ended up with the exact same linear equation. Now, just a little bit of extra practice again for what we just did. If you guys want some extra practice, up here on the top right of your page, you guys have some corresponding textbook pages that you can use with our online textbook to try out. But we're going to put in a couple more examples here. I'm not going to go over this slide because we just did so. And we're really just trying to go from one form to the next. Okay, so we can try out a couple of examples together. And we're going to go ahead and try these ones out. So here we're going to go and convert it into slope-intercept form. Again, we know that slope-intercept form is just y is equal to mx plus b. So we want to isolate the y, or just get that y by itself. Okay. So we're going to go ahead and start with example number 1. And just because we also want to identify the point that's given, just for extra practice here, let me highlight this. We want to try to find the point x1, y1. So that would actually be this right there. Oops, let me get rid of that actually. So we've got this. I'm having some technical difficulties again. Jeez. We're going to end up with this point. And we're going to end up with this point right here. Okay, so that means that our actual x1, y1 that we'd have to identify would mean that we're going to be working with the point 2 and positive 8 there. Okay, please do not be thrown off by the fact that it's y minus 8 and x minus 2. You almost want to be thinking the opposite. What is x minus your x1? Well, if x1 is 2, then we just have a 2 there. Okay, so we're going to go ahead and turn all of these equations into slope-intercept form. So I'm going to go ahead and simplify first your right side. So we've got 4 times x and 4 times negative 2. It's a little bit small on my iPad, I apologize. So 4 times x and 4 times negative 2. So you have y minus 8 is equal to 4x minus 8. I'm going to add 8 to both the left and the right sides. And I am left with y is equal to 4x. And that would be my linear equation in slope-intercept form. Now for my second example here, I am given y minus a negative 8 is equal to 2 times x minus a negative 3. So I'm having a lot of technical difficulties tonight. I've got y minus this negative 8 here, and if I can figure out, there you go, my 2 points, I should be able to identify this point as a positive 3. So positive 3, or sorry, not a positive 3, negative 3, and negative 8. So notice here, if I were to simplify this y minus a negative 8 would be the same thing as y plus 8. Okay, but here my y1 is actually negative 8, and my x1 is actually a negative 3. So we can go ahead and simplify this a little bit. When we subtract a negative 8, we actually end up with y plus 8. We can distribute 2 times x. So you've got 2 times x, and then 2 times negative 3. So I've got 2x plus 3 there. And let me go back a step. So here we've got 2 times x plus 3 if you want to simplify it first. So you have y plus 8 is equal to 2x plus 6 because we want to go and distribute the 2 times x and the 2 times a positive 3 there. Okay, to finish this one off, we're going to subtract 8 from both the left and the right sides. So we're going to subtract 8 from both sides there, and we are left with y is equal to 2x minus 2, which is my linear equation in slope-intercept form. Okay. For the last two here, we can go ahead and identify your point for this one here. This would be a negative 2, positive 4. And if I were to simplify, I've got y minus 4 is equal to 3x plus 6. All I had to do was distribute the 3 to the x and the 3 times the 2. And then we're going to add 4 to both the left and the right sides. So y is equal to 3x plus 10 as your final linear equation. And last but not least, example number 4, I want to make sure I distribute that 6, so 6 times x and 6 times negative 7. So we'd end up with y plus 3 is equal to 6x minus 42. And oops, before I forget, your point that we were using for this particular example would be positive 7 and a negative 3. So in order to solve this, or to isolate for y, we're going to subtract 3 from both the left and the right sides. And finally, we're left with y is equal to 6x minus 45. Okay, and again, if you're in need of more examples, go back to this page 372, and try out those practice problems just to give you a little bit more practice with this particular concept. Now, moving on to the last part of our lesson today, we're going to talk about how to graph point-slope form. Again, it's going to be really, really straightforward once you've actually converted point-slope form into slope-intercept form, which is exactly what we did on the last page. Okay, so we want to first convert it into slope-intercept form, and then we're able to graph it from there. Okay, or alternatively, what we could do is we could find a second point on the line and then draw our line through there, because we do know the slope, and one point on the line, we can figure out a second point on the line as well. Great. So example number 1, we've got y minus 3 is equal to 4 times x minus 2. Let's go ahead and identify your slope. So in this case, your slope is just a 4. And we want to identify your x1 and your y1. So over here, we've got 2, 3. And we want to go and plug in, or rather not plug in, we want to plot this first point here, 2, 3. So 2, 3 is going to be right here. So 2, 3 ends up being right over here. Since we know that the slope is 4, we would have to count up 4 this way, 1 to the right. But because we don't have any room there, we're going to go backwards. So we're going to go 4 down, 1, 2, 3, 4 down, and 1 to the right. So we're going to end up with a second point here. We continue to do that. 1, 2, 3, 4 points down, or 4 units down, and 1 to the left. And we're going to draw a nice straight line through those 3 points. So we would get something that looks like that. Again, at this point, pause your video, try out the next 3 examples on your own, and then continue to watch to check to see if you've got your answers right. So we're going to try out the example number 2. We know that our slope is just a 2 here, and we've got our point in this case, which happens to be -3 and a -2. Your slope, like we said, was a 2. So let's go ahead and plot this point, -3, -2. So -3, -2 is right down here. And then our slope is 2, which means that we're going to count up 2, and then 1 to the right, up 2, 1 to the right, up 2, 1 to the right. And then we're going to draw a nice straight line through those points. All right, example number 3. Again, we're going to look for your slope. That's the first thing we're going to do. And our slope in this case happens to be 3. And then we're going to look for your point, which is going to be -2, +4. I know, again, it's going to be a little bit confusing because I say your point is -2, +4. You almost want to be thinking we're going to take the opposite signs. Is maybe a little mental reminder for yourself. So we're going to fill in our slope is 3, and then we're going to have -2, +4 as my point. So we're going to use -2, +4 as our initial point that we're going to plot here on the line. So -2, +4 is right up here. And we know that our slope is 3, which means that we would have to go up 3, 1 to the right. You don't have enough room here, so we're going to go the opposite direction. 1, 2, 3 down, and 1 to the left. 1, 2, 3 down, 1 to the left. And then we can go and connect those points with a nice straight line. And again, just make sure that your plotted points are visible so you can see where you guys have actually decided to plot each of your points. Now the last example for today, we're going to look again at your slope, which is 6 in this case. And then we have your point 1, positive 3. So we've got a slope of 6 and 1, negative 3. Excuse me. 1, negative 3 is your point that we're going to graph. So 1, negative 3 is going to start all the way down here. We know that our slope is 6, so we're going to go up 6. So 1, 2, 3, 4, 5, 6, and then 1 to the right, which would be right here. You don't have enough room for any other points, so then I can connect those with a nice straight line. And that's our lesson for today, guys. Thank you so much for watching. If you have any more questions, please feel free to send me an email. Let me know where you're having any struggles. Use those practice pages. And as always, make sure that you guys keep an eye out for the next video lesson. Until then, stay safe, wash your hands. See you in the next lesson.